Our entire world is composed of positive and negative energy streams. As these energy streams propagate through space, they produce an oscillating energy field that has magnitude and orientation. These energy streams are not found in isolation, but if we could view a single stream, we would see that, for the most part, the orientation of the field stays consistent. It is only the magnitude of the field that is oscillating. An electromagnetic wave is formed when a positive and negative stream join together to form a neutral stream. These streams are held together by the strong force, which I will be discussing in a moment. In order for this bond to be established, the streams must be oscillating at the same frequency. They must also be aligned so that their fields are oriented in opposite directions, with their energy fields growing and shrinking out of phase with each other. When two streams are joined together in this manner, there will be areas in which the two fields cancel each other out in terms of orientation. The destructive interference between the positive and negative field will give the electromagnetic wave a combined energy field pattern with an orientation that is continually alternating. This is essentially the alternating field around which James Clerk Maxwell developed his theory of electromagnetism. But at the time, it was thought that electromagnetic waves consisted of two separate energy fields, a magnetic field and an electric field. Although this belief still exists in modern theory, I propose that all physical interactions are actually driven by a single type of field, which I refer to simply as an energy field, and the forces that we call magnetic, electric, and even gravitational are all natural responses to this one energy field. In order to understand why these forces exist, we must gain a better understanding of the behavior of energy streams and the structure of elementary particles. This video is intended to provide a very brief overview of these concepts. I will not be discussing the mathematics or the scientific evidence that supports this theory, but this information can be found in my book, The Unified Field Theory by Jesse Chandler. There are four forces that affect the motion of energy streams, and they account for all physical interactions within our universe. Although three of these forces are generally known, they are also greatly misunderstood. The first is the Lorentz force, which is applied to an energy stream when it is moving through a directional external field. This is perhaps the most accurately understood of the forces described in modern theories. I purposely avoid using the term electromagnetic force because some of the interactions that we currently consider to be electromagnetic are equally dependent on the other three forces. I use the term Lorentz force because it is responsible for both the electric and magnetic force described in the Lorentz force equation. The distinction between positive and negative streams is not found in the energy field they produce, but rather in the way that the streams themselves respond to a directional external field. When a single stream is moving perpendicular to the orientation of the external field, a force will be applied to the stream in a direction that is perpendicular to both the motion of the stream and the orientation of the external field. The direction in which the force is applied will depend on whether the stream is positive or negative. In this animation, the external field is oriented into the screen, causing the positive stream to be forced to the left and the negative stream to be forced to the right, just as we would expect for particles. We cannot observe this behavior with electromagnetic waves because any force that is applied to the positive stream will be balanced by an equal and opposite force applied to the negative stream, and in most cases, the forces will not be strong enough to overcome the strong force bond which holds the streams together. The behavior dictated by the Lorentz force also determines the direction in which energy streams circulate within a particle relative to their own field orientation. These circulating streams produce what we call an electric field, a field which is defined by a specific orientation and a direction of motion. Both of the particle streams shown here are oriented with their fields directed into the page, so the field that spreads from the positive stream on the left will be rotating counterclockwise, and the field that spreads from the negative stream will be rotating clockwise. Once we understand the structure of particles, we find that both of the components described in the Lorentz force equation are applications of the same principle. The only difference is that a magnetic interaction involves a moving particle in a stationary external field, and an electric interaction involves a stationary particle in a moving external field. Either way, the principle is the same. The Lorentz force is applied as a result of the motion of the streams relative to the directional external field. In an electric interaction, it doesn't matter how the particles are oriented. If we were to flip the orientation of one of the particles, the motion of its field would be reversed. But the orientation of the field would also change, so the result would be the same. The energy field from a particle appears to exhibit spherical spreading, but not in the manner in which we expect. To visualize the spreading in three-dimensional space, it helps to divide it up into two-dimensional components. The energy field spreads out perpendicular to each energy stream, so when the stream is following a straight path, there will be one component in which it spreads radially, and one component in which no spreading occurs. This gives us cylindrical spreading. When the stream is circulating in a closed loop, the field will exhibit radial spreading in both dimensions, resulting in spherical spreading, but only within the circulation plane. When we look at the spreading of the field along the axis, we are still dealing with cylindrical spreading. At every other angle, the spreading will not be purely cylindrical or spherical, but will be somewhere in between. When we are dealing with the Lorentz force, the effective strength of the field does not just depend on its magnitude, but it depends on the product of its magnitude and velocity. When we look at the motion of the field, we see that it increases linearly with distance along the circulation plane, but remains constant along the axis. Since the Lorentz force depends on the product of the velocity and the magnitude of the field, the effective strength of the field will decrease at the same rate in all directions. In order for the Lorentz force to take effect, there must be relative motion between the stream and the external field. When two or more energy streams are moving together so that there is no relative motion between their fields, it is the strong force that governs the interaction. This force depends on the alignment in the energy field oscillations. If the energy fields are growing and shrinking together, an attractive bond will be formed. Otherwise, the interaction will result in an anti-bonding force. It is the strong force that holds the electromagnetic wave together. This force exists independent of charge, so this type of attraction can also exist between neutral bodies. The strong force is responsible for the cohesive nature of laser light and the scattering of white light. It is the strong force that keeps the energy streams aligned within the core of the particle. Although the circular motion of the streams may have been initiated by the Lorentz force, it is actually the strong force that forces the streams to maintain their orbits. When the energy field oscillations are aligned, there will be no relative motion between the core streams. However, at each point along the ring, the streams will maintain perfect alignment to the energy field from the opposite side of the ring. The strong force is also responsible for the bond between protons and neutrons within the atom. This bond is similar to a relationship between gears. The connection can be made as long as the teeth are aligned and the gears are rotating at the same frequency. Obviously, two gears cannot be connected if they are rotating in the same direction, because their teeth will be moving in opposite directions at their point of contact. However, the connection can be made using an idler gear, which will be rotating in the opposite direction. Neutrons play an important role in the structure of the atom, because they essentially act as idler gears to bridge the gap between the protons in each of the atomic shells. This forces protons to maintain fixed locations within the atom. When electrons become bonded to these protons, in the areas marked in red, their locations will also become relatively fixed. At the moment, I won't be getting into detail on proton-electron bonding, but a more detailed discussion on this can be found in my book. The circular motion of a particle's field establishes a magnetic polarity within the particle. The motion of the field can be cancelled out when an identical particle aligns itself on the opposite side of the atom. In this situation, these particles are said to have opposite spin, and their combined field exhibits no detectable motion. The magnetic polarity of a particle or atom affects its ability to bond. Even neutral particle fields may repel if their fields are moving in opposite directions. When an atom contains particles that are not matched by particles of opposite spin, the energy field that surrounds the atom will reflect the same circular motion as the particle fields that are not being cancelled out. This gives the atom magnetic properties which allow it to bond to adjacent atoms. On a larger scale, the interaction between bar magnets follows the same basic principle as the interaction between atoms. In this case, the oscillation pattern may not be distinguishable, but if the atoms within the material have their poles aligned, their energy fields will all be circulating in the same direction. This will result in a combined energy field that is circulating at a high velocity, The interaction between bar magnets is not driven by the strong force as we see at the molecular level. Instead, this interaction is driven by the velocity potential of the energy streams, a topic which I will be discussing in part 2 of this video segment.